Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today I'll be posting my first video on DCET questions on the subject of microcontroller that is based on 8051 chip. Okay, so let's see the portion what is given for the DCET in this subject. Now, in this subject shows that features of RISC, CISC, that is reduced instruction set computer and complex instruction set computer. Then you have Harvard and von Neumann architectures, then microprocessor microcontrollers, then variants of microcontroller 51 series, then architecture of 8051 microcontroller, memory organization, 8051 addressing modes, instruction set, IO ports, embedded C, interrupts of 8051, timers and counters of 8051, serial IO, interfacing of displays, ADC analog to digital converter, DAC digital to analog converter, stepper motor and DC motor. So interfacing of all these three with 8051 will also be there. Okay, so based on this syllabus, there will be objectives asked in the subject for 7 marks. That means 7 questions will come on microcontrollers. Okay, so let's start with the first question over here. So the first question says that the CISC stands for. Now CISC, as we have seen from the beginning, CISC is complex instruction set computer. So it has complex instructions and the number of instructions are also more. Okay, so that is called as CISC. So here CISC stands for complex instruction set computer. So in these options, option D will be the correct one, complex instruction set computer. Okay, next we'll go to question number 2. The computer architecture aimed at reducing the time of execution of instruction is. Okay, now the architecture either CISC or RISC will be there, and from that also if you want to reduce the time of execution of instructions, a very few instructions will be there which require less number of machine cycles, and then they are reducing the time of execution, and that is done only in RISC. So here the answer should be B, RISC. Okay, the computer architecture which is aiming to reduce the time of execution of instructions is a reduced instruction set computer, RISC. Okay, then we'll go to next question. The RISC, that is a reduced instruction set computer processor, has a more complicated design than CISC. This statement is false because RISC has very few instructions. It is simple in nature. The design also is simple. It is not complicated. Complications come when you go for CISC. Okay, that means this statement is false. So here the answer will be false. Okay, so RISC processor is not complicated. It is a simple processor. Okay, so it's a simple design. Clear? Then we'll go to the next question. Question number 4. Both the CISC and RISC architectures have been developed to reduce the options are cost, time delay, semantic gap, and all the above mentioned. Okay, now here the answer will be answer C, that is semantic gap. As I've shown below, semantic gap is the gap between the high level language and the low level language. Okay, so to reduce that gap, both these architectures are being developed, CISC and RISC, complex instruction set computer and reduced instruction set computer. Okay, so they have been developed to reduce the semantic gap, the gap between the high level language and the low level language. Okay, so here the answer should be answer C, semantic gap. Okay, then we'll go to the next question, question number 5. Pipelining is a unique feature of. Okay, so what does pipelining means? Pipelining means you are making the instructions to stand in a queue, and one by one they will be fetched. Okay, so that instruction in the queue is called as pipelining. So in a queue they will be there, and the pipelining will have a procedure to fetch it, to execute it. Okay, to fetch or to execute it and to write it, all these procedures will come in pipelining. So you can have 3-stage pipelining, you can have 5-stage pipelining. Okay, so in that way pipelining stages also can increase. So the instructions in the queue can be fetched at every machine cycle, and one by one work can be done. At first they will be fetched, then they will be read, then they will be executed, then the answer will be returned. Okay, so these type of work can be done in pipelining. Now pipelining is a process which will help you to process or execute faster. Okay, and this process is used in a reduced instruction set computer, that is RISC. Okay, so here the answer should be RISC. Pipelining is a unique feature of RISC. Then we'll go to next question, question number 6. Which of the architecture is power efficient? Which of the architecture is power efficient? Obviously, a reduced instruction set where the execution of instruction is done faster. Okay, so the access time is faster and instructions are very simple. Okay, so there the power required is less. So obviously RISC is the one which will which has a power efficient. It is efficient in power consumption. Okay, and therefore this architecture is very suitable for mobile devices where power matters a lot, which you provide through a battery. Okay, so this RISC architecture is one which is power efficient. So here the answer should be answer B, RISC. Okay, then we'll go to the next question, question number 7. Which is the first company who defined RISC architecture? Which is the first company which defined RISC architecture? So as I've shown below, in 1970s, the IBM, International Business Machines, identified RISC architecture. So here the answer will be IBM. Answer B, IBM will be the answer. This is the company who defined RISC architecture first. Then we'll go to the next question, question number 8. How is memory accessed in RISC architecture? Okay, now in RISC architecture, or even when you study the ARM series and all afterwards, in RISC architecture, load and store type of instructions are used. Loading loading of data into memory, storing of data into memory. Okay, so loading the data from memory, okay, to the register, and storing the data from register to the memory. Okay, so these are load and store instructions. So load and store instructions are used in RISC architecture. Okay, so here the answer should be A, load and store. So how is memory accessed? Memory, if you want any data from the memory, you have to load. You have to use load instructions. If you want to store any data in the memory, then you can use store instructions. So load and store instructions. Clear? Then we'll go to the next question. Who coined the term RISC? Okay, so out of these 4 names, David Patterson, von Neumann, Michael J. Flynn, and Harvard, out of these 4 names, the first name, David Patterson of Berkeley University, he is the person who coined the term RISC. Okay, so RISC was first coined by David Patterson. Clear? So here the answer should be option A, David Patterson. Then we'll go to the next question, question number 10. Which of the following processors has CISC complex instruction set architecture? So the answer to the options over here are AVR, Atmel, Blackfin, and Zilog Z80. Okay, so out of these, the first 3, AVR, Atmel, Blackfin, are using RISC architecture. They are based on RISC architecture. Whereas the last option, Zilog Z80, is the only option in this 4 which uses or which has CISC architecture. So here the option will be D, Zilog Z80. So Zilog Z80 is the processor which has CISC architecture. Clear? Then we'll go to the next question, question number 11. The disadvantage of CISC designed processor is, okay, so the options given here are low burden on compiler developers. Option B is wide availability of existing software. option C is complex in nature, and option D is none of the above. So out of these four options, the third option, that CISC is complex in nature, its design is complex, that is the disadvantage, that is the main disadvantage, important disadvantage of DISC. So CISC's important disadvantage is it is complex, its design is complex in nature. So here the option will be option C, complex in nature. Okay, disadvantage of CISC design. Then we'll go to question number 12. The RISC architecture is preferred to CISC because RISC architecture has. So the options here are simplicity. Obviously, it is very simple. Efficiency, obviously, its efficiency is better than CISC. High speed, obviously, its execution time is faster, its access time is faster, okay, than CISC. That means A, B, C, all the three factors are there in RISC as compared to CISC. So here the option should be all of the mentioned. So D, all of the mentioned. Simplicity, efficiency, and high speed are the things which are advantageous in RISC as compared to CISC. Clear? Then we'll go to the next question, question number 13. The feature of RISC that is not present in CISC. Okay, the feature of RISC which is not present in CISC. So the options here are branch prediction, pipelining. Option C is branch prediction and pipelining, and option D is none of the above. So it is both. It is both branch prediction. So you're going to predict where you're going to branch, okay, and pipelining for the faster execution. Okay, so branch prediction and pipelining, both the features are there in RISC that are not present in CISC. Clear? Then we'll go to the next question, question number 14. So question number 14 is, which of the following is an application of RISC architecture by adding more instructions? Okay, so for RISC architecture, if you add little more instructions, which applications can take place? So here the options are option A is multimedia application, option B is telecommunication encoding, option C is image conversion. Now all these options, all these applications are there: multimedia applications, or telecommunication encoding, image or conversion. All this can be done by RISC architecture by adding few instructions, few specialized instructions to it. Okay, so here the answer should be all of the mentioned. So option D will be the correct answer here. Then we'll go to the next question, question number 15. In order to implement complex instructions, CISC architecture use. So what does CISC architecture use in order to implement complex instruction? So for complex instructions, you have to write small programming, that is microprogramming. So microprogramming is the answer. Microprogramming is one which can implement complex instructions in CISC architecture. So here the options should be C, microprogramming. So all other options, macroprogramming, hardware, and none of this will not be there. Microprogramming is the answer to implement complex instructions in CISC architecture. Okay. Then we'll go to question number 16. The advantage of RISC processor is, okay, so here the options given are can operate at high clock frequency, option B is shortened design cycle, option C is simple and fast, and option D is all of the mentioned. Okay, so I think all these options are true in case of RISC. So it can operate at high clock frequency, it has a shorter design cycle, it is simple and fast. So all the above mentioned will be the advantage of RISC processor. Okay. Then we'll go to the next question, question number 17. Which of the following is not true? Is not true about reduced instruction set processor, RISC. Okay. So the first option is addressing modes are less. This is true. Pipelining is the key for high speed. This is also true. Microcoding is required. No. Microcoding is not required in RISC because you don't want to make any instruction complex. So microcoding is not required. So option C is not true. Single machine cycle instructions is true. Okay. So here option C is one which is not true about RISC processor, reduced instruction set computer processor. Okay. Then we'll go to the next question, question number 18. The RISC processors that support variable length instructions are from which company? The RISC processors that support variable length instructions are from which company are given below? Intel, Motorola, AMD, or Intel and Motorola. So here the basic companies which were there which support variable length and instructions are Intel and Motorola. So Intel and Motorola have many ICs of microcontrollers and other things which have this RISC processors which are based on RISC design that support variable length instructions. So the option D will be the right one. Intel and Motorola, both the companies. Okay. Then we'll go to the next question, question number 19. The reason for which RISC processor goes to idle state or stall, it becomes idle, okay, like standstill, stall state. Okay, the reason for which RISC processor goes to idle is, so option A is delay in reading information from memory, option B is poor instruction set design, option C is dependencies between instructions, and option D is all of the mentioned. Okay, now the first three things whatever has been given, delay in reading information from memory or poor instruction set design and dependency between instructions, all these are true. All these are the reasons for which the RISC processor goes into idle state. So here the option should be option D, all of them mentioned. Okay, option D, all of them mentioned. Then we'll go to the next question, question number 20. Which of the following is not a characteristic of a RISC architecture? So after these four options, which is not a characteristic of RISC architecture? So option A is large instruction set. No, this is not true because it has small instruction set. One instruction per cycle. This is also not true. Okay. Then simple addressing modes. This is also not true. Register to register operation. This is also not true. Okay. So here the first thing which is there, that is large instruction set, because RISC is having a simple instruction set. It is not having large, it is having very few instructions. So that is why it is called as reduced instruction set. Okay, so option B, C, D are true, but option A is not true. Not true because it is having a simple instruction set, it is having a reduced instruction set. So this is not a characteristic of RISC. So here for question number 20, option A will be the right answer. Large instruction set is there for CISC, not for RISC. RISC has reduced instruction set. Okay, so it has few instructions in its instruction set. So here option A is not a characteristic of RISC architecture. Okay, so these were the 20 questions first which were depending on RISC and CISC architectures which I had taken for the first 20 MCQs of microcontroller which is based on 8051. Okay, so again students, here again I'm going to say you the same thing. See that whenever you study any chip, your basics of the chip starting from the pins, its hardware, okay, its architecture, okay, and then you can study about the instructions and then you can study about the programming. So start from hardware, see all its features, and then go to the instruction set and then go to the programming and then do interfacing and other things. Okay, that is the way you have to study a microprocessor or microcontroller chip. Okay, so these are my first 20 questions in this first video. In my second video I will be posting you another 20 questions. Thank you students.